So the partial fraction expansion method means something where you will be given your question, which will be something like this, right? Denominator getting multiplied. You somehow try to represent it in terms of this templates, 1 divided by 1 minus alpha z to the power minus 1 kind of templates, and then afterwards you compare it and you observe the ROC carefully, and based on that you determine whether it is right sided sequence or left sided sequence. Okay, that was the usual approach, the power series expansion method. Now let us see what is a partial fraction expansion method also. Now let us see sorry, the power series expansion method. Okay, so here is a question. So whenever the questions are on power series, they explicitly mention use a power series expansion method. Okay, so this actually is a very simple question. Actually, 2 divided by 1 minus 1 by 2 z to the power 1 by 2 z to the power minus 1 plus z to the power minus 1 divided by 1 minus 1 by 2, right? It's a very simple problem only, but since he has mentioned to use a power series expansion method, that's what makes it kind of interesting. Okay, so in your exams also you will be given questions very very specifically. You should check which method they are expecting you to solve. Okay, let us see what are power series first. What are power series? Here, these things are called as power series. You see this example, x to the power n. First thing you can see is the value of n here. The power series contains infinite number of terms, right? It contains infinite number of terms, and you can see here, I don't know why it is called power series, but you can see here the power 1, 2, 3, 4, right? The power of some term in the bracket, it goes on increasing, right? The power in the bracket, it goes on increasing, and it may be multiplied by a constant. It may be multiplied up by a constants like these. Okay, and sometimes divided by certain factorials which also go on increasing, right? You want to study this, right? Arithmetic series, geometric series, and this is a special case of arithmetic series. Okay, where you will have all the summations only. Okay, no multiplications here, all are summations only, but then their power goes on increasing. The trick is to given this kind of expression, right? Then you given these kind of series, you should be right, you should be able to write them in these kind of formats, right? You should be able to write them in these kind of formats. What sort of power series, by the way, that we have come across? Some popular power series, let me tell you, are your, remember your first year C programming, there you studied this thing, what was that, sine series, right? Sine series, cos series. Sine series is a power series. I hope you, whether you know or not, right? This is what sine series actually is, right? This is what sine series actually is. Sine is x divided minus x cube by 3 factorial plus x to the power 5 by 5 factorial minus x to the power 7 by 7 factorial, and so on, right? And so on. Okay. So if at all you are given sin x, then the tricky part here is you need the knowledge of mathematics. So you should know what a sine series actually means, right? Not only sine, actually you can say the exponential e to the power x is also, it's also a power series, right? A cos x is also a power series. 1 divided by 1 minus x, strangely, this is also a power series. This is the case when magnitude is, this is the usual formula, right, that you always apply whenever you get a summation x of n from 0 to infinity. If magnitude x is less than 1, then you simply substitute 1 divided by 1 minus alpha. Remember, that is this particular series. Okay. So which are the other series, by the way? E to the power x, sine, cos, tan is also a series, logarithm, lan, natural log is also a series, lan is also a series. Okay, so little tricky part this is, you should know little knowledge of mathematics here. Okay, anyway let us see what sort of problems are asked. Okay, so here is a question. So what it says is, find the inverse Z transform of this particular thing here. Find the inverse Z transform of this particular thing here, and he wants you to determine the inverse Z transform using the power series expansion method. Okay, using the power series information. Okay, let us see. Let us see. How do we get started? ROC has been given here. ROC has been given here. Magnitude Z greater than 1 by 2. That's what they have mentioned. ROC has been given here. Okay, ROC has been given here. Let us get started. ROC, what does it indicate? It indicates that we have a right-sided sequence. Okay, ROC here indicates that we have a right-sided sequence. ROC outside circle is a right-sided sequence. Okay, okay. Now let us see. Yeah. So now, whenever we have something like this, proper fraction, right? This is fine. Okay, this is fine. We simply go for a long division. Okay, what we do is we simply go for a long division method here. Okay, we simply go for a long division method here. Okay. So, what is long division method? Yeah, numerator derived by denominator. But the way we do it is, since it is a right-sided sequence, a right-sided sequence will have x of z equal to x of n z to the power minus n. If x of n is right-sided, you are going to get negative powers of z. If x of n is left-sided, you are going to get positive powers of z. That is why what you should do is, you should make sure that you have your entire z in negative power. The quotient shall be negative powers. How are you going to do it? See the clever way the author has written both the divider and the divisor and the dividend. Okay, you see here 2 is first, then plus z to the power minus 1, 1 minus 1 by 2 z to the power minus. Remember the previous class? In the previous class also we did one this thing here in the previous class, the long division here also we had some similar question. Here 1 minus c. Here what we did here was we wrote 2z to the power minus c. The one which is coefficient which is free of any z is here, and this one is here. We chose to write it the other way, the one with the maximum power of z. That's what we wrote first, and with reference to that only we started dividing. Okay, similarly here what we will do, yeah, similarly you can see what we are doing here is we start with this coefficient writing, we go on dividing. So 1 into 2, 2 minus 2, 2z, right? 1 into 2z, and so on and so. You can see this will keep continuing for infinite number of points. We stop after some 4 iterations. After some 4 or 5 iterations, we find the pattern here, and that is where we stop. Okay, we find pattern here and we stop. And now you can see which is our answer here. By the way, whatever we have in the quotient is our answer. Suppose I have 18 divided by 6. If at all my quotient is 3, this is also fine. This 3 is also fine, right? Both of them are my answers only. Okay, so here also something similar. Here also this is something similar. Okay. So now my answer is, now let me write these things in this particular manner, x of z, and then when I write x of z like this, then what is the inverse? Now I am ready. Okay, so you will get as many points as possible in this, and then afterwards we'll start finding the inverse z trans. What is the inverse z transform of 2, by the way? uh, hmm? Inverse z transform of 2 is 2 only. Okay, 2 into delta n it is. Remember, 2 into 1, this inverse z transform is 2 into delta n. Okay, 2 into delta n exists only at 0, right? At 0, amplitude is 2. Similarly, 2 into z to the power minus 1. What is the inverse z transform of 2 into z to the power minus 1? 2 is 2, constant is constant. This is delta n minus 1, which exists at plus 1. Similarly, 1 into delta n minus 2, half into delta n minus 3, and so and so. So finally, here you have your answer. Okay, so here you have your answer. Okay, now What makes the question interesting is the second part. Okay, what question makes now the same question, x of that is being now they say ROC is now inside the circle. Okay, now when they say ROC is inside the circle, see here carefully, how did we write these things? First there is 1, then there is the factor of z, right? First we wrote the constant, then those coefficient with other values of z we wrote. Now what we'll do for ROC less than 1 by 2 in this particular case, okay, in this particular case, now we'll expand in a power series with positive powers of z. Now also the way we write here is, now instead of 1 I will write it as minus 1 by 2 z to the power minus 1 plus 1. Instead of 2 plus z to the power minus 1, I will write it as z to the power minus 1 plus 2. Okay, meaning does not change, but you can see the way the coefficients have come out strangely are in positive powers of z. So whenever they say ROC is inside the circle, you have to go for long division such that you get to expand in positive powers of z. And when you get the values in positive powers of z, then your sequence will only have values on the left side. Okay, then you have the values only on the left side. Okay, so here we are, same problem. What was the trick here? The way they write the divider and the dividend, the way they write the divider and dividend, that is what is making the difference here. Okay, that's what makes the difference here. Now what is the z transform of minus 2? What is the z transform of minus 2? It has a minus 2 into delta n, which occurs at n is equal to 0. What is the z transform of 2 8 into z? Minus is a minus only. Okay, minus 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 minus, yeah, that is fine. Okay, so what is the z transform of, what is the z transform of uh, 8 into z? What is the inverse z transform? Sorry, what is the inverse z transform of 8 into z, by the way? What is the inverse z transform of 8 into z? Constant is a constant, so here also you will get an 8. And what is it, by the way? 1. The z transform of delta n, z transform of delta n is 1. Okay, z transform delta n is 1, and k into delta n is k into 1. Okay, so 8 into some constant should be 8 into constant is a constant anyway. Now this 1 gets multiplied by z, 8 into 1 into z. So multiplication by z in the z domain results in a shift in the time domain by same factor, delta n plus 1. Okay, so you have delta n 2 into minus 2 into delta n minus 8 into delta n plus 1, which occurs at minus 1, minus 16 into delta n plus 2, which occurs at plus 2. Okay, minus 32 into delta n plus 3, which occurs at minus 3. Got this particular thing? So how did we solve this numerical, by the way? They asked us to solve it using power series expansion method, and we did so. What did we do? We saw what is their ROC requirement. Based on that, we wrote the divider and the dividend accordingly. And if at all we write the divider and dividend in this particular manner here we get the values in positive powers of z, so that we want to expand it as left-sided sequence, whereas if at all we want it in negative powers of z, say that it is a right-sided sequence, then what we have to do? We have to write the constants first, okay, and then we have to go for the division. Okay, then we have to go for the division. Okay, now let us see one more example. Okay, now here in this example, so what is it, by the way? Here also they have given both the cases. So that this is an important question. Okay, this one here is a important question. Okay, it's a tricky question. Okay. This part is tricky. Part is tricky. Okay, okay. So how they have done there? This is a simple problem actually. So now we know what is it. summation alpha to the power n, summation alpha to the power n, the n going from 0 to infinity, summation alpha to the power n going to is equal to 1 divided by 1 minus alpha, right? We know this, right? We know this. Now here we have 1 divided by 1 minus alpha. This term is alpha. So that is why, what is this, by the way? So this entire term indicates this power series. This entire term indicates this power series. Here you can see. So this x of z here indicates alpha to the power n. Okay, okay. He has written k. Fine for us. Fine for us. Alpha to the power k. This is so that what should be the inverse z transform? Okay, so that what is it should be? This was fine, right? Now you can see magnitude z greater than alpha indicates a right-sided sequence. Okay, this indicates a right-sided sequence. So that you can see here z is in already negative powers. This is in the right format. We do not have any issue. How do you find the inverse here, by the way? In inverse, since the system is linear, the superposition theorem satisfied and summation will remain summation, even in z domain, even in time domain. Summation will remain summation. The constant will remain constant. 1 by 4 to the power k will remain 1 by 4 to the power k. Only thing you have to find is the inverse z transform of z to the power minus 2. What is the inverse z transform of z to the power minus 2? Z to the power minus 2 into k. So what is this, by the way? So 1, if at all, sorry, if at all 1 has an inverse z transform of delta n, if 1 has an inverse z transform of delta n, 1 gets multiplied with z to the some power, right? Multiplication by z, right? That is shift in the time domain. So delta n, what is this, by the way? There is a minus here, by the way. Yes, so here is minus delta n minus 2k. That's that. We are done. Okay, so 1 by 4 to the power k delta n minus 2k from this particular thing, minus 2 into k it was, right? We applied it here also, we applied it here also. So there it is. This was simple. The tricky part is here. Here they say, so this x of z corresponds to this expansion with a minus sign here, with a minus sign here. So it's fine for this case. But here author mentions that magnitude z is less than 1 by 4. Here author says magnitude z is less than 1 by 4. What that means? That means now we have to rewrite this expression. Now we have to rewrite this expression so that my z is going to have negative powers only. Sorry. Z is going to have positive powers only. How do I do that? How do I make sure that Z is having positive powers only? What author has done here cleverly is he has taken Z to the power 2 outside. What author has done is he has taken Z to the power 2 outside, and he has done something with 4 also. Okay, this was I don't know why this thing was done, but anyway it makes sense, right? This entire expression here, you can see this is tricky. Okay, you have to write this thing on your notebook only and understand. Okay, you have to write this thing on your notebook only to understand. Okay, write this thing on your notebook only to understand. But you can see the way this thing has been written here, the way the thing has been written here is such a way that the meaning of the expression did not change, but you have now the entire expression in positive power of z. That suits my ROC requirement, that it's a left-sided sequence. Once you get this thing in positive power of z, you simply take this thing outside, take the constant out. It's here he cleverly took this thing inside. Now he started with this, then he has cleverly taken this thing. So 4 z to the power 2 term taken outside, and he got this particular thing. If at all you have signals and systems by Uday Kumar, right, any addition will do. He has this problem, very nicely. He has expanded this expression. You can go through that also. Okay. So you can see once he gets this particular thing z, you can see it's still in positive power Now it is easy. So delta 2 to the power k plus 1 is delta n plus 2 to the power k plus 1. This is your inverse Z transform. Okay. So what is this particular thing? So if at all you are given expression like this, either you expand them in right-sided sequence or you expand them as right-sided sequence, left-sided sequence, right? Things get tricky. Things that get tricky when you are given questions something like these, right? When you are given question something like this, right? So what's the tricky part in this question here? What's the tricky part in this question here? They have simply given x of z equal to e to the power z square. X of z equal to e to the power z square. Now the question is, do I know e to the power z expansion of this one, right? If at all I have it in this particular format, it is easy for me. It is easy for me. So here there is one constraint. We should know this particular series. Okay, you whether you learn by heart or you from your mathematical knowledge, whatever it is, right? I had shown you earlier, right? Some of the series on your last page of your notebook. You should have this series. Okay, you should have this series here. You can see e to the power x is 1 plus x plus s square by 2 factorial plus x to the power 3 by 3 factorial and so on. In place of x we have z square. So this 1 plus z square, z to the power by 2 factorial, z to the power 6 by 3 factorial and so on. Okay, so that is why this particular thing here e to the power x is written as x to the power n is summation. Okay, similarly you should know how to write the expression and how to generalize them also. So here you can see on the same grounds this expression has been written as alpha to the power k by k factorial. Okay, alpha to the power k, a to the power k, okay, whichever, a to the power k by k factorial. In place of what, a to the power k, in place of a, what do we have? We have z square. In place of a we have z square. So this is z to the power 2k divided by k factorial. Okay. So what will be this z transform here, by the way? So this inverse z transform of this will be, inverse z transform of this will be, summation will remain summation only. Summation will remain summation. Then k 1 by k factorial will still be there. K factorial will still be there only. Okay. K factor will still be there. Z to the power 2k will result in delta n plus 2k. Delta n plus 2k. Okay. So this will be my inverse Z transform. And since this is delta n plus 2k, you can see author writes that it does not have any values on the right side. And what is this delta n plus 2k? What does that indicate? This indicates that this one here will exist at, say, shall I substitute? Shall I try to draw this particular thing? Delta n plus 2k. Delta n plus 2k. Okay, with k going on only on the positive side. So this exists on the negative. For k equal to 0, this is delta n. For k equal to 1, this is delta n plus 2 at 2. For at minus 2. For k equal to 2, this is delta n plus 4 at minus 4. What this thing? See, at minus 3, minus 1, it is all 0. That is why what I say, this is 0 for n is equal to odd. Okay, this is 0 for all values of n. This is 0 for positive values of n also. Now where does it exist, by the way? Wherever it exists, whichever the value it exists at that particular point, the amplitude is still is going to be n divided by 2. That means for n is equal to 1, this will be n delta n plus 2k. For n is equal to 2, right? For every value, the corresponding n value will be divided by 2. That's what. I don't know. This is not a comfortable. I think if at all you write this much, this is sufficient. Okay. This would be sufficient. Okay. What other series do we have, by the way? Yes, here is your cos series. You can see he says that z should be greater than 0 only. Cos series. Where is the cos series? Here is the cos series. You can see here is the cos series. What does it say? Cos x1 minus x square. Okay, 1 minus x square plus x to the power 4. So it all expands into x to the power 2n divided by 2n factorial. But he wants it to be right sided. Actually, he has given z to the power minus 2 there. So that is why this thing we will have a minus in the bracket and everything will turn out to be fine. Okay. That is why let us see how they have done this thing. Let us see how they have done this. Hmm. So cos z to the power minus 3. So just as we saw in that particular formula, minus 1 to the power k, what does that indicate? Minus 1 to the power k indicates alternate change in the signs, right? Minus 1 to the power k here indicates alternate change in the signs. Did you see that series earlier? Did you see this series? You can see some of the series here. Exponential, no, exponential series is having all positive values only. Here you can see minus, plus, minus, plus. Here also minus, plus. That is why to indicate alternate change in the sign, that's how your sign series is, right? So it's like growing, decaying, always saturating. So for alternating change in sign, they simply write minus 1 to the power n, they indicate. Then you can see here the denominator. See here, this is not 1 2, this was easy, right? 1 2. This was simple here. 1 2 3 4. This is also 1 2 3 4. So x to the power n. Here you can see how you will generalize this. 1357. 1357 can be written as 2 into n plus 1. If n is equal to 0, it is 1. N is equal to 1, it is 3. N is equal to 2, it is 5. So that is why it's a trick to generalize this. Okay. Similarly, see, this is 1357. This is 1246. Here what you have to do? You simply need to write 2n. Okay, not n plus 1. Similarly, the factorial also 2n plus 1 factorial, because there's 3 factorial factors here, 2n factorial. Okay. So this thing here, is yeah. So for this particular term cos, okay, what they have done, minus 1 to the power k. So in place of alpha, this is the thing which you are supposed to by heart. Okay, this is what you are supposed to by heart, or you should know. Okay, I think cos series, sine series, logarithm, exponential, and natural log, all the things you are supposed to know. Once you see it, you will remember those. Okay. So minus 1 to the power k, minus 1 to the power in plus alpha, we have z to the power minus 3. Thank God it will expand in negative powers, right? So there is no conversion needed. Z to the power minus 3 to the power k, z to the power minus 6k. It became all these things here. See, all these things, the summation and the constant remain same. Thank God, since it is an LTI system. Only thing is z to the power minus 6k turns out to be delta n minus 6k. Okay, this turns out to be delta n minus 6k. Okay, so questions are easy. Only thing is you should know the series properly. Only thing is you should know the series properly. Okay. What about this one, by the way? This is one more natural log. This is one more natural log. You can see here all natural logs will have an 1 plus the coefficient. This is because these coefficients z can anytime go to 0, and logarithmic of 0 is, what is the log of 0? Log of 0 is minus infinity, right? Log 0 is minus infinity. That is why what happens sometimes, this may get into trouble. That is why to avoid the situation, there is always in natural log 1 is inbuilt. So here is the template of the natural log. Here is the template of the natural log. So in place of alpha, we substitute z to the power minus 1. Remaining thing, let them be same. Only thing is delta n minus 1 into k, that is minus k. So here is your answer. Okay. So that was about inverse z transform using power series expansion method. So in exams, you are supposed to see it carefully, what they have asked. And based on that only you are supposed to attempt. Okay. Let me stop here today. So I intend to what conduct. I intend to conduct a test tomorrow. Okay, I intend to conduct a test tomorrow based on basic Z transforms. Okay, basics of Z transforms. I will not ask derivations or anything, only simple questions only I will ask. And the questions will be, the simplicity of questions will be, such that, one with, a simple preparation should be able to answer it. I will ask questions. I will show you, either you can interact with me on chat on the answers, or maybe you can write them on a sheet. Okay, so I will start in the morning same time at 11 o'clock, and I will continue till till the time runs out, half an hour. I will ask questions, whatever comes to your mind. Take a white sheet and go on writing. Okay, take a white sheet, go on writing. Take a white sheet and go on writing. And then I will see how much marks to give. It depends. Okay, depends on what sort of questions I will ask. Okay. So, and this time they are telling that the internals are sort of difficult for us to conduct, right? There is an uncertainty. In such case, these tests or the assignment marks, they only will be taken into consideration, and they carry maximum weightage. So whether some of your friends were complaining and all, I can't help it. Okay. So I'm not even referring to, asking you to refer to my class. There are so much nice videos available on internet. And I have decided not to upload the videos also from now on. Takes a lot of time, and my bandwidth is also, and I don't know. Okay, so that's why what you do is, be prepared tomorrow. Okay, the topic is basics of Z transform. Okay, no derivation, nothing. Properties, numericals on properties and properties of ROC will be asked. Okay, we will meet tomorrow. Thank you. Inform your friends also. Okay.